Hello everyone. In this video we are going to cover following topics. First is, what is software testing? Then, why we do software testing? After that, types of software testing. And also we are going to cover the difference between white box testing and black box testing. So let's get started. What is software testing? Software testing is the process of finding defects, bugs in a software application, or execution of software with an intention to find defects is called as software testing, or verification of application against requirement specification is called as software testing. Software testing is a critical phase in the software development lifecycle, encompassing various processes and methodologies aimed at ensuring the quality, reliability, and performance of a software application. At its core, software testing is about more than just finding defects or bugs. It's about validating that the software meets the specified requirements, functions as expected, and delivers value to its users. In this comprehensive exploration, we'll delve into the intricacies of software testing, examining its importance, key concepts, methodologies, and best practices. Importance of software testing. Software testing plays a pivotal role in delivering high-quality software products to end users. By identifying and fixing defects early in the development cycle, testing helps reduce the cost and time associated with resolving issues in later stages. Moreover, thorough testing enhances the reliability, usability, and performance of software, thereby enhancing user satisfaction and trust in the product. Understanding defects. At the heart of software testing lies the concept of defects, commonly referred to as bugs. A defect can be defined as any deviation or discrepancy between the actual and expected behavior of a software application. These discrepancies can manifest in various forms, including functional errors, performance issues, security vulnerabilities, and usability shortcomings. Identifying and resolving defects is essential to ensure that the software functions correctly and meets the needs of its users. The software testing process. The software testing process typically comprises several phases, each serving a specific purpose in ensuring the quality and reliability of the software. These phases may include 1. Requirements analysis. This phase involves understanding and analyzing the requirements of the software to establish a basis for testing. 2. Test planning. Test planning involves defining the testing objectives, scope, resources, and timelines. It also includes identifying test scenarios and designing test cases based on the requirements. 3. Test case design. Test cases are designed to validate the various functionalities and features of the software. They outline the steps to be executed, the expected outcomes, and the criteria for determining the success or failure of each test. 4. Test execution. In this phase, the designed test cases are executed against the software under test. The results are recorded, and any defects encountered are reported to the development team for resolution. 5. Defect tracking and management. Defects identified during testing are logged into a defect tracking system, where they are prioritized, assigned to developers, and tracked through resolution. Effective defect management is crucial for maintaining transparency and accountability throughout the testing process. 6. Regression testing. As changes are made to the software to address defects or introduce new features, regression testing ensures that existing functionalities remain intact and unaffected by the modifications. 7. Release and deployment. Once testing is complete and all critical defects have been addressed, the software is prepared for release and deployment to production environments. Methodologies and approaches. Software testing encompasses various methodologies and approaches, each with its own set of principles, techniques, and best practices. Some of the most commonly used methodologies include 1. Waterfall model. The waterfall model follows a linear sequential approach with distinct phases for requirements, design, implementation, testing, deployment, and maintenance. 2. Agile testing. Agile testing is an iterative and incremental approach that emphasizes collaboration, flexibility, and adaptability. Testing is integrated into the development process, with frequent feedback loops and continuous improvement. 3. Scrum. Scrum is a specific framework within the Agile methodology that divides the development process into short, time-boxed iterations called sprints. Testing is performed continuously throughout each sprint, with a focus on delivering incremental value to the customer. 4. WBT emphasizes the integration of development and operations teams to achieve faster, more reliable software delivery. Testing is automated and integrated into the continuous deployment (CI/CD) pipeline, enabling rapid feedback and seamless deployment. Next topic is why we do software testing. Every software is used to support business. If there is any problem in software, defect or bug, it is going to affect directly consumers, customers, business, so find all the possible and try to fix it. To improve the quality of product, software. To check whether the application is working according to the customer requirement specification. Software testing is essential for ensuring the quality, reliability, and performance of software applications. By identifying and fixing defects early in the development cycle, testing helps reduce the risk of costly errors and rework later on. Testing also enhances the user experience by validating that the software meets the specified requirements and functions as expected. It helps mitigate security vulnerabilities, ensuring that sensitive data and systems remain protected from potential threats. Testing provides confidence to stakeholders, including customers, investors, and regulatory bodies, that the software is of high quality and complies with industry standards and regulations. Additionally, testing helps uncover usability issues, ensuring that the software is intuitive and easy to use for end users. It facilitates continuous improvement by providing feedback to developers and enabling them to iterate on the software's design and functionality. Ultimately, software testing contributes to the overall success and longevity of software products, fostering trust and satisfaction among users and stakeholders alike. Next topic is types of software testing. Software testing is divided into two major types. First is white box testing. It is also called as unit box testing. And second type is black box testing. It is also called as open box testing. What is white box testing? Testing the each and every line of source code is called as white box testing. White box testing, also known as structural testing or clear box testing, is a software testing technique that examines the internal structure of a software application. Unlike black box testing, which focuses on the external behavior of the software, white box testing delves into the code, algorithms, and architecture to uncover defects. This testing method requires a deep understanding of the underlying codebase and is typically performed by developers or specialized testers who have access to the source code. White box testing techniques include statement coverage, branch coverage, path coverage, and condition coverage, among others. By analyzing the code paths and execution logic, white box testing aims to ensure that all code branches are tested and that the software behaves as expected under different conditions. One of the primary benefits of white box testing is its ability to uncover hidden defects and vulnerabilities that may not be apparent through black box testing alone. However, white box testing can be time-consuming and resource-intensive, as it requires detailed knowledge of the code and thorough test case design. Despite its challenges, white box testing is an essential component of a comprehensive testing strategy, helping to improve the overall quality and reliability of software applications. Second type is black box testing. What is black box testing? Verification of application against requirement specification is called as black box testing. Black box testing is a software testing technique that focuses on the external behavior of a software application without examining its internal structure or implementation details. Testers approach the system as a black box, interacting with it based on its specifications, inputs, and expected outputs. This method simulates how end users would interact with the software without knowledge of its internal workings. Black box testing encompasses various techniques, including equivalence partitioning, boundary value analysis, state transition testing, and error guessing, among others. By validating the functionality, usability, and reliability of the software from an end-user perspective, black box testing helps identify defects, errors, and discrepancies between expected and actual behavior. One of the key advantages of black box testing is its independence from the underlying codebase, making it suitable for testing software developed by third-party vendors or teams. However, black box testing may not uncover all defects, particularly those related to internal logic or implementation flaws. Nevertheless, when combined with other testing methodologies, Black box testing forms an integral part of a comprehensive quality assurance strategy, ensuring that software products meet the needs and expectations of end users. Let's start new topic. Difference between white box testing and black box testing. Definition of white box testing is testing each and every line of source code is called as white box testing. And definition of black box testing is verification of application against requirement specification is called as black box testing. Next difference is white box testing is usually done by software developer or rarely done by software tester. And black box testing is usually done by software tester either manually or through automation. Next differing white box testing is also called as clear box testing. And black box testing is also called closed testing. Next difference is it is mandatory to have knowledge to programming to perform white box testing. And to perform black box testing, knowledge of programming is not required. Next difference is white box testing is the logic testing of the software. And black box testing is the behavior testing of the software. Another difference is white box testing is a structural test of the software. And black box testing is a functional test of the software. Next difference is white box testing is generally applicable to the lower levels of software testing. And black box testing is applicable to the higher levels of testing of software. Next difference is white box testing of software is started after a detailed design document. And black box testing can be initiated based on the requirement specifications document. Next difference is example of white box testing is by input to check and verify loops. And example of black box testing is search something on Google by using keywords. Next difference is types of white box testing. First is path testing, second is loop testing, and third one is condition testing. And black box testing types are following. First is functional testing, second is non-functional testing, and third is regression testing. This all types also divided into several types. We will discuss on it in upcoming sessions. Next difference is which tools are used for white box testing and black box testing. For white box testing we used JUnit and TestNG means test next generation. And for black box testing we used Selenium, QTP. QTP stands for Quick Test Professional, Cypress tools. Next topic is types of white box testing. White box testing is divided into three types. First is path testing, second is loop testing, and third is condition testing. Let's start with path testing. Path testing is a method that is used to design the test cases. In the path testing method, the control flow graph of a program is designed to find a set of linearly independent paths of execution. In this method, cyclomatic complexity is used to determine the number of linearly independent paths and then test cases are generated for each path. It gives complete branch coverage but achieves that without covering all possible paths of the control flow graph. McCabe's cyclomatic complexity is used in path testing. It is a structural testing method that uses the source code of a program to find every possible executable path. Next point is path testing techniques. First technique is control flow graph. The program is converted into a control flow graph by representing the code into nodes and edges. Decision to decision path. The control flow graph can be broken into various decision to decision paths and then collapsed into individual nodes. Independent paths. An independent path is a path through a decision to decision path graph that cannot be reproduced from other paths by other methods. Advantages of path testing. The path testing method reduces the redundant tests. Path testing focuses on the logic of the programs. Path testing is used in test case design. Disadvantages of path testing. A tester needs to have a good understanding of programming knowledge or code knowledge to execute the tests. The test case increases when the code complexity is increased. It will be difficult to create a test path if the application has a high complexity of code. Some test paths may skip some of the conditions in the code. It may not cover some conditions or scenarios if there is an error in the specific paths. Second type is loop testing. Loop testing is a type of software testing type that is performed to validate the loops. It is one of the type of control structure testing. Loop testing is a white box testing technique and is used to test loops in the program. Objectives of loop testing. The objective of loop testing is: first objective is to fix the infinite loop repetition problem. Second objective is to know the performance. Third objective is to identify the loop initialization problems. And fourth objective is to determine the uninitialized variables. Types of loop testing. Loop testing is classified on the basis of the types of the loops. First type is simple loop testing. Testing performed in a simple loop is known as simple loop testing. Simple loop is basically a normal for, while or do while in which a condition is given and loop runs and terminates according to true and false occurrence of the condition respectively. This type of testing is performed basically to test the condition of the loop whether the condition is sufficient to terminate loop after some point of time. Second type is nested loop testing. Testing performed in a nested loop is known as nested loop testing. Nested loop is basically one loop inside the another loop. In nested loop there can be finite number of loops inside a loop and there a nest is made. It may be either of any of three loops, i.e., for, while or do while. And third type is concatenated loop testing. Testing performed in a concatenated loop is known as concatenated loop testing. It is performed on the concatenated loops. Concatenated loops are loops after the loop. It is a series of loops. Difference between nested and concatenated is that in nested loop is inside the loop but here loop is after the loop. And last one is unstructured loop testing. Testing performed in an unstructured loop is known as unstructured loop testing. Unstructured loop is the combination of nested and concatenated loops. It is basically a group of loops that are in no order. Advantages of loop testing. The advantages of loop testing are: first advantage. Loop testing limits the number of iterations of loop. Second advantage is, loop testing ensures that program doesn't go into infinite loop process. Third advantage is, loop testing endures initialization of every used variable inside the loop. Fourth advantage is, loop testing helps in identification of different problems inside the loop. Next type is condition testing. Condition testing is a test case design method which ensures that the logical condition and decision statements are free from errors. The errors present in logical conditions can be incorrect Boolean operators, missing parentheses in a Boolean's expression, error in relational operators, arithmetic expressions, and so on. Advantages of condition testing. First advantage is it ensures that our test cases have checked all the conditions or not. Second advantage is with condition coverage, we can detect bugs in early stage and can fix them firsthand. Third advantages is thorough testing of all possible conditions improves the reliability and maintainability of the software. Fourth advantage is thorough testing lowers the risks of errors, improves the quality of our tests, and helps meet quality standards. Thank you for watching this video.